All right, today we are jumping into one of the most powerful ways AI is being used in the real world: predictive maintenance. We're going to explore how we're teaching our most complex, most expensive machines to actually tell us when they need help before they break down. It's all about maximizing uptime and honestly keeping our high tech world running. Okay, let's get into it. In the most advanced factories on the planet, the places making the chips that power, well, everything, the most terrifying sound isn't some loud crash or a bang. Nope, it's silence. Because when that multi-billion-dollar orchestra of machinery just stops, every single second is an insane amount of money down the drain. And that really gets to the heart of the problem, what we call the uptime imperative. See, in these industries where equipment is pushed to the absolute edge of what's physically possible, reliability isn't just a nice to have, it's the very foundation of the entire business. The stakes, both financially and for production, are just astronomical. And to put a number on that, check this out. It can cost $20 billion to build a single modern semiconductor factory, or fab as they're called. $20 billion. When you've made that kind of investment, you literally can't afford for it to be sitting idle. These places are designed to run 24/7 full tilt. Anything less and you're falling behind. So this really lays out the two different worlds of manufacturing. On one side, you've got tool downtime. That's the nightmare scenario, right? You're losing money, your schedules are a mess, and all those expensive materials you were working on, they're basically scrap now. But on the other side, you have efficient production, and that's the dream. You're cranking out as much as possible, your schedules are rock solid, and profitability is way up. The big question is always, how do you make sure you stay on the right side of that line? Well, for decades, the answer was traditional maintenance. But honestly, it's a pretty flawed system. You either have these scheduled fixes where you're replacing parts on a calendar, whether they need it or not, which is just super wasteful. We call that over-maintenance. Or the other option is you just wait for something to break, which is a total catastrophe. And for smaller production runs, a full-on preventative program like that can be way too expensive to even consider. There just had to be a better way. And that better way is here. Thanks to AI, we're seeing this massive shift in strategy. We are moving away from just reacting to problems and moving toward actually predicting the future. And this is the whole idea behind predictive maintenance, or PM. It's all about using AI to create a smart, self-aware system that can see failures coming before they ever happen. And the goal isn't just to stop things from breaking, it's to squeeze every single ounce of performance out of the equipment. We're trying to maximize something the industry calls overall equipment effectiveness, or OEE. The easiest way to think about OEE is like a report card for your factory. It measures how close you are to running at your absolute perfect potential. This really nails the difference in mindset. Traditional maintenance is all about just in case. Let's replace this part just in case it's about to fail. But predictive maintenance is just in time. The AI looks at all the data and says, hey, this specific part is good for another 72 hours, so let's schedule its replacement for the next planned break. It's the difference between guessing and actually knowing. And this ability to know what's coming, that's the holy grail in manufacturing. It sounds like magic, but how do you really do it? How does a silent box of metal and wires learn to, raise its hand and tell us that it's starting to feel sick? Well, the answer, as you probably guessed, is data, a massive, nonstop fire hose of it. It's about outfitting the equipment with a whole new suite of senses, letting it constantly check its own vital signs and report back on even the tiniest changes. So the very first step is what we call condition monitoring. Think of it like strapping a Fitbit onto a giant, complex machine. It means capturing time series data, so a constant stream of measurements, not just single snapshots. And what's really important here is tracking things like the total runtime for a specific job or the exact number of times a component has done its task. This kind of sequential, time-stamped data is what lets the AI build a complete life story for every part, which, fun fact, is something a lot of the big language models today still struggle with. And here's where it gets really, really smart. A lot of this health checking actually happens when the machine is idle, basically on its coffee break. In those quiet moments, the equipment runs a self-diagnosis. It's analyzing how its own parts are interacting with the tiny, microscopic bits of material left over from when it was running. It's an unbelievably clever way to check its own health without ever stopping production. Then, the second step is layering in a whole network of advanced sensors. This is like giving the machine a full-blown nervous system. You've got power and current monitors that are listening for tiny changes in how much electricity is being used. Why? Well, because a motor that's starting to wear out has to work a little harder, so it draws a little more power. That's a huge tell. At the same time, you might have special cameras that can see inside the machine, looking for any kind of contamination that could ruin the final product. Every sensor adds another piece to the puzzle, creating this incredibly detailed picture of the machine's health. So, all this data collection, the condition monitoring, the advanced sensors, it's all building towards one single ultimate goal. This is the real magic of predictive maintenance, the power to actually see the future. And that future is measured in something called remaining useful time, or RUT. Now, this isn't some vague guess, it's a very precise AI-powered calculation. It takes all that sensor data, all that runtime info, and it estimates exactly how much longer a specific part will do its job properly before it's likely to fail. So you're not just told, hey, this thing is wearing out. You're told you have 48 hours of useful life left on this component. That changes everything. This quote just sums up the whole revolution perfectly. For 100 years, maintenance has been about fixing what's already broken. Predictive maintenance is all about acting on what is going to break. It completely flips the script from being reactive to being proactive. And the impact of knowing the future? It's profound. You can replace parts with surgical precision right before they fail. You stop wasting time and money on fixes you didn't need yet. The AI can even suggest tiny tweaks to the production process to take some stress off a part and make it last longer. All of this feeds back into creating a perfectly optimized schedule, turning the whole factory into this incredibly intelligent, finely tuned system. This technology is already transforming our most advanced industries, making them more efficient, more reliable than ever before. But it does leave you with one last, really fascinating question to think about. If AI can give our machines a voice, what other silent systems in our world, from our power grids all the way down to our own bodies, are just waiting to tell us their secrets?